Welcome. This is our project on experimental study on steel fiber reinforced concrete in beam column joint under cyclic loading. This project is submitted by Ajit, Murthy, Prasant and Venkatesh. These are the batch members. This is done under the guidance of Mr. Krishna Kumar Adityan. Introduction. The recent earthquakes reveal the importance of the design of reinforced concrete structure with ductile behavior. Ductility can be otherwise described as the ability to deform without failure under tension or load. Conventional concrete loses its tensile resistance after formation of cracks. However, fiber concrete can sustain a portion of its resistance following cracking to resist more cycles of loading. This is the concept of our project. Objective: to evaluate the performance of conventional reinforced exterior beam column joint as per IS 456 and as per IS 13920, and provide a comparative study of the results between these column models, beam column joint models. Literature review. Mr. Chowdhury AM and Laskar studied this type of materials. Similarly, Vivek Verma and Praveen in 2013 also conducted a study on experimental investigation of structural behavior beam column joint. Ganeshan and Indra PV, DSF or HPC joints studied these type of joints. Perumal P and Tanukumari B in 2010 presented the result of seismic performance of the hybrid reinforced beam column joint. Similarly, here Andrew Zone and et al., the foreign members, they tested bending tests on 18 moderate scale beams of load approximately 5 lakh cycles. This is the methodology. First, literature review, then we purchase the materials, then we mix the materials based on the mix ratio. It is then molded, setted and cured for 24 days. Then it is tested for and result is concluded. This is the details of the specimen. Four numbers of 6 mm dia bars were used for the main bars in column, and 4 numbers of 8 mm dia bars for beams. The dimension of the beam was 110 into 110 mm and column was 110 into 110 mm. The cast specimen 4 wooden molds were fabricated. The size of the beam was 500 into 110 into 110 and the column was 600 into 110 into 110. This is the description of the field work. This is the image. These are the basic tests done. These are the materials: cement, ordinary Portland cement, water, fine aggregate, coarse aggregate and concrete. Steel, the main reinforcement 6 mm dia steel bars and the shear reinforcement 2 mm dia bars. Fibers, steel fibers were used. These are the steel fibers. This is the undulated type of steel fibers we have used. Properties of fibers: the length is 50 mm, diameter 1 mm, aspect ratio 50, modulus of elasticity and tensile strengths are given. These are the reinforcement details for beam column model 1, 2, 3, 4 and 5. Percentage of steel fibers are vary accordingly, 0 to 0.5. These are the length provided for the fiber: LD minus 50, LD plus 50 for the last two things. This is the image for BCM 1. This is the image for BCM 2. This is casting and curing. Normal casting, we have to put the fibers for the LD distance and we have to cure it and we have to test it. This is the casting stage of beam column joint. All the specimens were tested in a UTM of 100 tons capacity. This is the testing image. These are the results for cycle 1, cycle 2, cycle 3 and cycle 4. This is the load versus displacement representation. This is the displacement graph showing for the BCM 1. Similarly, for the second specimen, we have tablet column, and this is the graph showing the displacement for different cycles for the beam column model 2. Similarly, this is the third beam column model and it's a cyclic loading procedures for displacement. This is fourth. The beam column model fourth graph showing different cycles of loadings are given here. This is for the fifth beam column model. The readings were noted and the graph is plotted for the different cycles of loading. This is the energy dissipation versus deflection curve. The readings are noted and the graph is plotted similarly for the energy dissipation versus displacement. This is This tabulation is to find the ductility factor.
Displacement.
Yield and ultimate displacements are noted, and then ductility factor is provided. This is the conclusion. Steel fibers bridging across the cracks in the concrete restrain the crack propagation. The practical difficulties in placing and consolidating the concrete in beam column region can be avoided. Here, by using the beam column joint, by using fibers in it, we can increase the ductility. This is the conclusion. It gives us high ultimate strength, high load carrying capacity, finer cracks in the joint region, more ductility, more energy dissipation, and very less joint distortion in the fiber joint. These are the references. Thank you.